everyone, welcome to my channel, Tutorlini Test Prep. Today we'll be going over official guide number 4, Geometry and Trigonometry. This video will cover the Geometry and Trigonometry section of the official digital SAT study guide, a preparation book made by College Board. Please support the book by purchasing your own copy using the link in the description. I recommend you complete the questions before watching this video. You can follow along beginning on page 283 in your own copy of the 2023 edition. Let's get started. All right, so very first thing is I'm going to recognize kind of what this question is asking me about. This is a similar triangles question. We know they're similar because they tell us they're parallel. This guy and this guy are equal based on vertical angles. This guy is a right angle. So that means because they're parallel. So that means this guy and this guy are equal. So we already have enough information to show that they're similar based on the AA criterion. But we can also go one further and recognize that this guy and this guy are equal because of corresponding angles of similar triangles. So let's just write that down. So why don't I do triangle ADE is similar to, that's what that symbol means, triangle purple, green, yellow, CBE. CBE by the AA criterion. Okay, so this guy is 1, and they want us to find AC. So we're probably going to have to find this length. Why don't I call it X? And we can find this length using the Pythagorean theorem for that top triangle. So let's do that. So a squared plus b squared equals c squared. And the two legs are 5 and 12. Make sure a and b are the legs. 5 squared plus 2 squared equals AE squared. 5 squared plus 12 squared, that is 169. And we take the square root of both sides. The square root of 169 is 13. So AE is equal to 13. So that's important. And let's put that on the picture. So this side is 13. Now, we've shown that they're similar using the angle criterion. I'll put that over here so you guys can see. But we now need to know what two triangles being similar tells us. So there's two important things. All the corresponding angles are equal, which we kind of already showed. And the corresponding side lengths are proportional. So I'm going to set up a proportion, big over small. That's how I like to do it. You can do like the sides within the triangle, but I like to do the side from the big and its corresponding side with the small. So we know we got to find X. So let's do the corresponding big side, yellow to purple, is 13. And the corresponding small side for that pair is X. Now let's do a set of sides where we have both sides. So the two that we have for both of them is this 5. See how that's green, yellow? And then this 1 is also green, yellow. So those two kind of go together. So big over small would be 5 over 1. If we cross multiply, we get 13 equals 5x. And we get x equals, divide both sides by 5, we get x equals 13 over 5. So to find segment AC, which is this big one here, we're going to do AC equals 13 plus 13 over 5. And we can just do that on a calculator. Let's see what that gives us. I'm getting 78 over 5. If you want, you can also put the decimal equivalent, which is 15.6. So either of those would be acceptable for our final answer. And that is correct. So there's a lot going on here. If you want a mental note, these two shapes like this, when you have a triangle that kind of makes like an hourglass, lots of people call those crossed triangles. And if you know that the two lines across from each other are parallel, you know they're similar. So you can kind of skip those kind of steps I was doing at the beginning if you can remember that. I don't know, up to you. Great, let's keep going. Okay, so regular just means all the sides and angles are equal. And it's got 9 sides, and it's got 9 congruent isosceles triangles. So that means those two sides are equal to each other. So there actually is a formula for the number of degrees of interior angle of the sum of the interior angles. I think it's 360 times n minus 2, where n is the number of sides. But so that's one way you could do it. But what they want you to do here is recognize that this is a circle. So it's 360 degrees. And if we split it 9 ways, that means each of those little like center angles is 40 degrees. I just got that from 360 divided by 9. Now, for isosceles triangles, something you have to know is that the base angles are equal. The angles across from where the two equivalent sides meet. So there's 180 degrees in a... So if this guy is x, then this guy is also x. A really quick mental way to think about it is to do 180 minus 40, and then half it, because you have to split it evenly. So each of those angles is 70. And that's it. X is 70. So make sure for a isosceles triangle, you know how to solve for all the missing angles if they give you one of them. You only need one. So if they give you one of the base angles, you got to know how to find the other two. If they give you the one where the two equivalent sides meet at the top, you got to be able to find the other two as well. So for this case, we just did 180 minus, so 180 minus 40, and then divide it by 2. That's it. Again, if you're having trouble seeing that, just write an equation and solve it, and you'll kind of get the same thing. Now, if you wanted to use the equation that I wrote above, you could do that too. So 360, 9 sides, 9 minus 2, 2,520. There's 9 angles. Divide by 9. I get... Is it 180 n minus 2, or let me see. Yeah, okay, I kind of messed up. It's not 360 n minus 2, it's 180 n minus 2. That makes more sense. Okay, anyway, so if you do 180 times 9 minus 2, you get 1260. You divide by the number of angles, so 9, and you get 140. So each of these big angles is 140, and because everything's symmetrical, the x is half of that, so 70. So that's another way you could have done it. I haven't seen a question that has required this in a really long time, but they do technically expect you to know it. Great, let's keep going. 70 is right. Okay, they're inscribed in a circle. Which of the following is true? So for this guy, what I'm seeing is this angle and this angle both subtend this arc. So they are equal because the arc is proportional to the arc it subtends is proportional to the inscribed angle. So those guys are equal. And then do you see how this angle and this angle both kind of intersect on this arc? So those guys must be the same. I wonder if there's an answer choice that says that AXB. Okay, so that's this one. is equal to the measure of AYB. Okay, so that's this one. Great. They both intersect their inscribed angles, and they both intersect the same arc. So they must have the same length. They must have the same measure. So that seems correct. Question 3 is C. Good. Okay, this one, weirdly enough, I just did this in my special right triangles video, and I swear I didn't look at this. It was just a total coincidence. Anyway, let's see if we can do it. So, the lengths of OB and AC are each 6. Okay, so this is 6, and this is 6. And then OA and OB are both radii. This is a radii, and this is a radii. So that means OA is the radius, which is 6. See how the radius OB is 6? So if OB is 6, OA must be 6. So that means that this whole side is 12. And it also says BC is tangent to the circle at B. So that tells us that this guy is a right angle. So let me kind of just draw this off to the side. We have like a triangle, and this guy is 12, this guy is 6, and you could, if you wanted to, use the Pythagorean theorem to find that other side, or you could just recognize that this is a 30, 60, 90. So see how this is x, and this is 2x because it's double. And that means this guy is x root 3. This is all on the reference sheet, guys, so you could pull up the reference sheet. It's also in my Ottocento special right triangles video, this exact question. Okay, so I'm looking at maybe this one, and I see that x is 6. And once again, this guy must be 30, that means, and this guy must be 60. Okay, so if he's 6, then that means this guy is 6 root 3. Okay, now we got to find the area of the triangle. The area of a triangle is 1/2 base times height. The base and height of a right triangle are both the legs. So we're going to do 1/2 6 times 6 root 3. And that is 36 divided by 2 is 18, so this should be 18 root 3. And now we have to find the area of this sector here. So that's the area of the triangle. And the area of the sector, well, sector area, I'll just call it SA, is theta over 360 times pi r squared. So the theta is 60. That's the central angle. I'll draw it here just to be clear. And 60 over 360 times pi r squared. The radius is 6. So we do 60 over 360. 60 over 360 times 6 squared. That gives us 6 times pi. So let me put a box around that, put a box around that. And now for our final answer. So if we want the area of that shaded region, we do the total encompassing area, which is the triangle, minus the unshaded region, which is the sector. So we're going to do the shaded area is the triangle minus the sector area. And so we're going to do 18 root 3 minus 6 pi. And let's see if that's B. Wonder if that's correct. Yep, that's right. Okay, I went through this a little bit fast, but again, if you're confused, please go watch my Ottocento video. I spend much more time going over special right triangles. And it is on the reference sheet, so some of it you don't need to memorize. However, you probably want to know this equation, central angle over 360 times pi r squared. And you definitely want to just be familiar with how to set up a special right triangle. That's probably the two really important things here, even though there's some other stuff like knowing that a tangent line means it crosses the point of tangency at a right angle, and knowing that a radii is the same everywhere on the circle. Those are like two smaller concepts they're testing you on, but the big thing is how to do a special right triangle and how to calculate area of a triangle and sector area. Great. Let's keep going. Okay, the area of a parallelogram with sides lengths A and B. Okay, so I'm kind of seeing that would be this. Like that would be this. The parallelogram is kind of like hiding within it. And how much greater is the area? Well, I guess, so if we want to compare this area to the big one, we just need to find the area of the triangle. So hopefully that kind of makes sense. So we have to find the area of that triangle on the right. It is a... Let's see. Well, this one is a 45, 45, 90, the one on the right. But I don't know what the height is. Okay, let's see. Okay, so let me see. Okay, so if this guy's a parallelogram, then this guy is 135. And then 180 minus 135 is 45. So this triangle is a 45, 45, and then 180 minus that would give us 90. So right away, this is going to be, this is on the reference sheet, S root 2, and in my special right triangle video. So now if we can just figure out one of those sides, we're in business. Well, this side we know is equal to A, because parallelograms, the sides across from each other are equal. So this one is A, and that means that S is equal to A. So I can write this as A, and I can write this as A root 2. I think we just have to find the area of that triangle, as I was talking about before. So the area of any right triangle, any triangle is 1/2 base times height. And then for a right triangle, the base and the height are just the two legs. So the two legs here are both A. So we should get 1/2 A squared, which is A, and let's see, that is correct. I think what's really hard about this one is just thinking to draw that line and like kind of making the plan. I feel like once you get started, it's not so bad. It's just, yeah, that was a really weird first step, that the parallelogram was like hiding within the trapezoid. Anyway, let's keep going. Okay, so we want to find the volume of a cylinder. This is on the reference sheet. Its volume equals pi r squared times the height. It says the radius is 2 inches. And the height is anywhere between 7.75 and 8. So why don't we do 7.8? I don't know. And we just kind of put this in here. 2 squared. So this equation is important, but you don't need to memorize it because it's on the reference sheet, so don't worry about it. And now we just put that in a calculator. Okay, that's it. Okay, so pi, it doesn't have a pi in the question or anything, so it wants to know literally what it is, not like what's in front of the pi. And it says rounded to the nearest cubic inch. So I'm getting like 98.017. So to the nearest whole number, that's 98. And let's see if that's right. Yeah, so they would have accepted 97, 98, 99, 100, or 101. And that is just depending on whatever you picked as your height. So as long as you picked a number between 7.75 and 8, you should get one of those answers approximately, and then you round it to the nearest whole number. So this was really confusing. See how it says to the nearest unit? That just means to the ones place. So I rounded this at the 8, the ones place. That's just a weird how we say to round to the nearest whole number when there's when it's a word problem. Great, let's keep going. All right. Okay, actually, I went over this a little bit. This is actually kind of like function translations using special points. Anyway, so the equation of a circle is x minus h squared plus y minus k squared equals r squared, where h comma k is the center and r is the radius. So looking at this one, you see there's no number kind of with the x. So that means the x coordinate h of the center is 0. And the y coordinate, there's a minus sign, so we have to circle this number but then change the sign. So it's not 0, 1, it's 0, negative 1. You got to change the sign. And then the radius is the square root of whatever comes after. So the radius for this one is root 4. The square root of 4 is 2, so the radius is 2. Now we want to find a center which is 1 unit up. So to move up, we add to y. So we're going to add 1 to y. And then we also want the radius to be 1 more. So we're going to add 1 to the radius. So the new center is 0, negative 1 plus 1 is 0. And then the new radius is 2 plus 1, which is 3. Now we can put those in to the original circle equation. So x minus 0 squared, or just x squared, plus y minus 0 squared, or just y squared, equals 3 squared, because 3 is the radius, and then 3 squared is just 9. And that is answer choice B. And 7 is B. Good. Yeah, and if you wanted to plot these on Desmos, I encourage you, go do that. You just type these in, type this one in, and then type all these other ones in, and see which one seems like it has a bigger radius, but the center moved up 1. You could probably figure it out pretty quickly, but you still want to know the circle equation, so don't get too reliant on that. Great, let's keep going. Okay, this is one of those circle equation ones, but we have to do work to get it like that. There's one of these in the Blue Book tests. So they do like asking this. It's probably still on the test. So what we're going to do is we're going to first organize, leave some space, and kind of get the make sure the constant is on the right side and everything's kind of in order, like x squared x, y squared y. And now we're going to complete the square. To do that, we're going to add b over 2 squared to both sides. So why don't I do the x's first? So the b is 8. It doesn't even matter the sign, because when you square it, it's going to become positive. 8 divided by 2 is 4. 4 squared is 16. So we're going to add 16 here, and we're going to also add 16 over here to both sides. And we can kind of put parentheses around this guy, hopefully kind of see where this is going. Now we're going to do the same thing with the y. So the y is 6 or -6. So you divide by 2 and you get -3. And then you square it and in parentheses and you get 9. So we're going to add 9 to both sides. So let's do that. So +9 and +9. And then we're going to group these guys. And I can get rid of this. Good. All right, so now we go to the right side. And we do 24 plus 16 plus 9, which is 49. And for those two guys on the left, you just have to factor them. Factoring with a equals 1. I go over it in my factoring video. You can check that out if you want. So it has to add to 8 and multiply to 16. So it's x plus 4 adds to 8 multiplies to 16, which is really x plus 4 squared. And for the y's, add to -6 multiply to 9. So if we did it right, it should be a perfect square. It's y minus 3, y minus 3. So see how those add to -6, but multiply to 9. So plus y minus 3 squared. So this is the equation. We did a bunch of work, but you can get it into its standard equation. And now we're going to find the center. We don't have to for this question, but let's just find it anyway. The center is, okay. Don't forget to change the signs. Remember, when we did the equation, guys, there's minuses in front of the h and the k, so you got to change the signs. So it's not 4, -3. That would be wrong. It's -4, 3. And the radius is the square root of whatever is on the right side because it's r squared. So r is square root of 49. The square root of 49 is 7. So this would be a center of -4, 3. And a radius of 7. This is one of the only questions where I actually think Desmos might help a little bit that we've done so far. So let's take a look. So I'm just going to type in the original equation. Hopefully I did a good job. And you guys kind of see we can like kind of plot the north and southmost point, and I'm going to label them. So when I call n north equals -4, 10, and I'll label it n. And then I'll label south, what's the south one? -4, -4. We'll label that with an S. Okay, so the center is the midpoint of those two. So let's type midpoint n, s. And then I click on label and it'll tell it to me. So -4, 3. Boom, we did a good job. And then the radius is the distance between the two of them is the diameter, and we divide by 2 to get the radius. So I think it doesn't like that I call that r, so why don't I just get rid of that? Okay, so the distance between the two of them is 14, and then you divide it by 2, that's the diameter, and then you divide by 2 to get the radius, and you get 7. Yeah, I don't know. I actually think if you know how to do that, that was actually not a lot of work. This question might be easier to do on Desmos in the heat of the moment, because I feel like a lot of people will make a tiny sign error with the completing the square or the factoring or something. Like they'll just make a tiny mistake and then the whole thing will be wrong. So I don't know. You do what works for you. I still encourage you to know how to do it by hand, just in case. Okay, so they're similar. It's almost like a trick question. Like, okay, so similar, see the similarity statement? The order that these letters are in tells you which angles correspond. x and p are equal, q and y are equal. It's kind of already labeled. And z and r are equal. So we want to find cosine of z. And do you see, kind of just from looking at the picture and from the similarity statement, we can kind of determine that angle z is equal to angle r. The measures are equal. Well, if we want to find the cosine of z, it stands to figure that the cosine of z is equal to the cosine of r. Hopefully that kind of makes sense, right? If they're the same and we put them into a function, you should get the same value, right? It's like if I did cosine of 2 and cosine of 2, like they're going to be the same, right? So they tell us cosine r, so now we can just swap that out. So cosine z is equal to 0.263, and that is the answer. That is it. So yeah, so basically if two angles are equal, all their trig values are equal. I think that's really all they're testing you on here. That and how to interpret the similarity statement, which we talked about, the order that the letters come in. The first guys go together, the middle guys go together, and then the last guys go together. Okay, great. That's right. Let's keep going. Okay, the coordinates of point B are negative root 2, root 2. What is the measure of angle AOB? Okay, so I'm going to first draw the reference triangle. So it's going to look something like that. You drop a perpendicular from that kind of dangling point with the x-axis. And if it's okay, I'll make it bigger so you guys can see. And we know that the coordinates of point B are negative root 2, root 2. So that means the x direction is root 2, and the y direction is root 2. And these two guys are equal. So this is an isosceles right triangle of the form like s root 2. I know that's kind of confusing. But these two guys are equal. So if both the legs are equal, you have an isosceles right triangle, or a 45, 45, 90. So this is 45. We don't have to do this, but if you want to find the hypotenuse, it's root 2 is s, and then s root 2 would be root 2 times root 2, which is just 2. Okay, anyway, really all we needed to realize was that this angle right here, that one, like right angle BO and then with the y-axis or x-axis, that is 45. That's what you needed to realize. And it's because these two sides are equal. Okay, and so if that guy is 45 and this whole guy is 180, then AOB will be 180 minus that 45. Which is 135. So that is the angle, but we have to convert it to radians. So always remember that there are pi radians in 180 degrees. That's just something you got to know. Don't really know how else to slice that for you. And we're going to do a unit conversion, 135 degrees. The 180 goes on the bottom. Pi radians goes on the top. And the degrees are on opposite sides of the division sign, so they cancel. And now we can just put this onto a calculator. You might have an easier time using a scientific calculator because it can handle pi really well. So this would be 3 pi over 4 radians, and that is answer choice C. And for sample question 10, that is correct. Great. There are some other things you could do if you have a scientific calculator. I think I don't know. Let's see if it works. I don't know. You guys want me to do it? How about I do it in degrees just because it's easier, but you could do it in radians. So, tan of theta is equal to y divided by x. That's something you learn in pre-calculus. And if I do tan inverse of y divided by x, so root 2 over negative root 2. And it tells me negative 45. That just has to do with the domain. So just think 45 and then think, okay, what's 45? Is it this or is it the reference angle? And the answer is it's the reference angle. So you just figured out the reference angle is 45, right? This is too big to be 45. That has to be bigger than 90. That's an obtuse angle. So it must be talking about this little one. So the little one's 45. Then you once again do 180 minus 45, and you get 135. And once again, guys, if you want, I'll just show you. So these like kind of natural view calculators are just really great because it can handle the pi nicely. And then if the question wanted like a decimal, you could just click this little button and change it to a decimal. So 3 pi over 4, it would be like 2.4 if they wanted you to round to the tenths. Great, so yeah, classic unit circle trig. But once you figure out it's 45, it's mostly just arithmetic. And again, I can't stress this enough, guys. This is not on the reference sheet. Pi radians equals 180 degrees. Make sure you know that. Okay, this is kind of just testing us on a formula that we should know for the test. Sine of x is equal to cosine of 90 minus x degrees. And cosine of x equals sine of 90 minus x degrees. And you guys see that, it's kind of testing us on the first one. So if it were in degrees, the k would be 90. It's just a concept you got to know. If sine and cosine are equal, the two angles add up to 180, and if add up to 90. And then if you're in radians, it adds up to 180 is pi radians. Anyway, so if you knew that formula, you're kind of already in business. So you just need to convert the 90 to radians. So let's do 90 degrees just like we did before. Pi radian over 180. The degrees cancel. And we get 1/2. So pi over 2 radians, and that is the value of k, and that is correct. So just make sure you understand, guys, that I don't really see this formula tested in radians a whole lot. It's usually in degrees. So if two angles add up to 90, then the sine of one is equal to the cosine of the other. And the reverse is also true. If the sine of one is equal to the cosine of the other, then they add up to 90. So just make sure you kind of understand that idea. I mean, if you want to memorize these equations, that's great, but you'll probably understand most questions better if you just kind of understand what I was just talking about. I've gone over this in other videos before, so I'm not gonna rehash it. All right, great. Let's move on to the drills. And let me just get all my stuff up here. Great. Okay, this one, we're just going to write an equation. All the angles have to add up to 180. So A plus 2B plus 31 equals 180. And A is 45. So 45 plus 2B plus 31 equals 180. And let's see, 45 plus 31 is 76, so 2b plus 76 equals 180. I'm going to subtract 76 from both sides. I get 2b equals 104. I'm going to divide both sides by 2, and I get b equals 52. And that is answer choice A. And that is correct. Great. Okay, so cube has a surface area. Okay, so this is not on the reference sheet, so if you want to write this down, you can. So cubes, they have a volume of the side length, the edge length cubed, and the surface area is there's 6 faces, and each face has an area of s squared. That's the area of a square. So 6 times s squared, or 6s squared. You could totally see these on the test. Great, so the surface area is 6s squared. So 54 is equal to 6s squared. Divide by 6, I get 9 equals s squared. Square root of both sides, and I get s equals 3. Now we can go and find the volume. So the volume is s cubed. Volume equals 3 cubed. 3 cubed is 27. So the volume of the cube is 27. Great, so you see you can kind of figure those out kind of like I did before, but I don't know, man, it's like test questions take a long time, so you might want to just know those equations. It might be worth knowing. The volume is s cubed, and the surface area of a cube is 6s squared. Okay, okay, so I would not even look at the answer choices unless you're going to use Desmos. I would just write the equation. So x minus h squared plus y minus k squared equals r squared. Okay, this is hk, and that's r. So we're going to do x minus negative 8, so x plus 8 squared, plus y minus 6 squared equals 5 squared. And 5 squared is just 25. And I think that's our answer. X plus 8 squared plus y minus 6 squared equals 25. Looks like option B. And that is correct. And if you were going to do this one by using Desmos, you could just plot the point and then type them all in. And whichever one looks like it has a radius of 5 and has that center is correct. Again, you really need to know how to do this. So, okay, which of the following would show that they're parallel? Okay, so first of all, in order for these two to be parallel, it has to relate something from here to something from here, right? If we just talk about something here, that doesn't tell us anything about line K. So it has to relate information from here to here. So the one that says x plus y equals 180, even though that's true, that tells us nothing about it being parallel because it doesn't mention z. And w equals y, that's also true, but it doesn't mention z or the other side at all. So that also does not tell us they're parallel. So if we just kind of realize that z had to be a part of it, that would have helped us a lot because we can now just take a 50-50 guess if we don't know what to do. All right, anyway, so the thing that they're almost always testing you for parallel lines is the corresponding angles are equal. So W equals Z, or X equals Z. So if you want, you could put the Z in its corresponding spot up here, or you could pull this stuff down here. I'll just pull the Z up here. So I see Z would be equal to Y if they were parallel, but that's not an option. So I go, what else is Y equal to? Well, Y is equal to W. So if Z were equal to W, it would also be equal to Y, and they would be parallel by corresponding angles. You could also use what's called alternate exterior angles, but I wouldn't worry about that. Great, so again, what we had to realize was that Z had to be equal to Y, and then Y is also coincidentally equal to W because of vertical angles. Angles across from each other in like an X shape are always equal. It's called vertical angles. Okay, 4 is B, good. I swear I've done this one before. Okay, anyway, let's draw it. So we're going to do one of the acute angles. So let's say x and y. So let's say the first one is tangent of x. So I can call opposite, tangent is opposite over adjacent. So toa. So opposite would be across from there. So that would be root 3. And then adjacent would be next to x. So that would be the denominator, 3. And if you want, technically they don't have to be root 3 over 3 or 3. They just need to be in that ratio. So if you want, we could put an a here. It doesn't matter. Okay, so now we're going to go to the other acute angle. So the y. So let's say we started with tan x. And now we're switching to tan y. So the opposite of y is now across from that angle. So 3a. And then the adjacent is the one next to it that's not the hypotenuse. So that's root 3a. And the a's cancel. We get 3 over root 3. And that's answer choice D. That's it. Yeah. I'm thinking another, something they might want you to do is to rationalize the denominator. So we would multiply the top and bottom by root 3. And we would get 3 root 3 over 3, which is just root 3. Let me make sure that's right. And if you have a scientific calculator that can simplify radicals, that can really help with questions like these. But you see, we didn't really need to do it for this one because they just left it as 3 over root 3. So what's the takeaway? Well, as you guys kind of saw, opposite and adjacent, when you switch acute angles, the hypotenuse stays the same, but the opposite and the adjacent kind of switch places. So when you switch tangent from angle to angle, it gets inverted because the two sides switch places. Great. Okay, we already did this. I'll write it again. So pi radians equals 180 degrees. Now we're going to do pi radians. There was already a question very similar to this. Type 90 over 180 into a calculator. You get 1/2. 1/2 times pi is pi over 2. Could also just use a scientific calculator. Again, guys, don't forget pi radians equals 180 degrees. Pi radians equals 180 degrees. Okay, so I'm actually going to go over this. So you can use the square formulas, but what they're testing you on here is scale factors. So the length scale factor we call capital K. And the perimeter scale factor is equal to the length scale factor. Perimeters and lengths are in the same ratio when we have similar shapes. The area scale factor is equal to K squared. And the length scale, or the volume scale factor, is equal to capital K cubed. So this is something you kind of want to understand. So you might be thinking, Kyle, this only applies for similar shapes, and they didn't tell us it was similar. Well, they didn't have to. There are 4 shapes that come up on the test that are always similar. Squares is one of them. So squares, circles, cubes, and spheres. If you see any of those shapes, they don't even need to tell you it's similar or not. Those shapes are always similar. Think about it, right? Circle, even if you change the radius, it has the same shape. So it's similar. Okay, anyway, so the length of one side of square m, so m is the bigger one, it sounds like, and it's 5 times the length of the corresponding side of square n. Okay, so m is the big one, and we're going to do, that's our length scale factor. Our k, our length scale factor is 5, because it's 5 times as big. Now, the area of square n, okay, so they probably want us to find the area scale factor. So the area scale factor is k squared, which would be 5 squared, which is 25. So that's important. Now, to find the area of m, we're either going to do 25, we're going to do the area 361, and we're going to either multiply it by that area scale factor of 25, or we're going to divide it by 25. So you got to think. Okay, they said square m is 5 times as big. Okay, so square m is the bigger one. So if I want to find the area of m, I should probably multiply by a whole number instead of divide. Because if I divide, it'll make it smaller. So we want to get a bigger number because we know square m is bigger. It has longer sides, right? So we're going to multiply 361 instead of divide by the area scale factor of 25. And we get 9,025. And that is the answer. So you can imagine they ask questions like this a fair bit where maybe they'll give you the area scale factor. They'll say, oh, the area scale factor is 81. And then you have to deduce, wait, the length scale factor is the square root. You take the square root and you get 9. And then you do something with that. So that's how these questions tend to shake out. So the area scale factor is k squared, and the volume scale factor is capital K cubed. These are probably things you want to understand. Great. Let's keep going. Okay, if sine k equals 105 over 233 and sine m equals 208 over 233, what is the value of tan s? Okay, so KLM, L and R are right angles. Okay, so I don't even know which one's bigger or not. So why don't I do KLM, then I'll make a bigger one, QRS. They're telling us about K. Okay, so let's just kind of make it clear though. This one's equal to this one because they're both first, right? And then the middle guys are equal. This is also a right angle. And this one's equal. And again, you can look at the similarity statement. They're in the same order. And then M and S are equal. So this one and this one are equal. Okay, angle K corresponds. Okay, so if sine K is 105 over 233, then it stands to figure that sine Q, the angle it's equal to, is also 105 over 233. And if sine M is 208 over 233, then it stands to figure that the one equal to him, S, is also 208 over 33. And let's see. I'm trying to do this without trig identities, which aren't on the test. They don't expect you to know those. I'm pretty sure we could just label these. So do you see for both of them, the hypotenuse, it's 233 really like x, but why don't we just say x is 1? Because it's not going to matter. So we'll put 233 or 233a. You could put like in my last one. And then the opposite, sine is opposite over hypotenuse. So the opposite across from S is 208. And then sine is opposite over hypotenuse. So the opposite across from Q is 105, or at least in that ratio. You could do a quick check of the Pythagorean theorem to make sure everything kind of checks out. I just did it on my calculator and it satisfied it. Okay, so we have those labeled. Technically, we should put A's after all of them, but I'm not going to really bother with that. Hope that's okay. Now we're going to do tan of S. So we're looking at angle S, and the opposite is across. The hypotenuse is across from the right angle, and the adjacent is the last side. And tan is opposite over adjacent, so 208 over 105. And that's actually too many. You can't put that in as, it doesn't simplify. So it's too many characters to put in as a fraction, because you can at most put 5 characters, not including a negative sign. So that's like 7 characters. So you have to just round or truncate until you run out. So you could put 1.981, which would be 1, 2, 3, 4, 5 characters. Or, and that's rounded. Or you could not round it and put 1.980, or in other words, 1.98. Do whatever works for you. I would just, so you don't mess up the rounding, I would just type until you run out. Like read it off your calculator and keep typing until you can't type anymore. Anyway, 1.981. You see it's like 1, 2, 3, 4, 5, and then you can either round or truncate. So you could put a 0, or you could round it up to 1 because there's a 9 to the right of it. So I think 1.981 makes the most sense. I don't know, really weird. They should just make it so that the fraction is less characters so that you can just put that in. Who knows? All right. Okay, ABC is similar to EDC. Which of the following must be true? Okay, so I'm going to go ahead and label these guys. So ABC, so A and E in the triangle. So see how I'm kind of like, if you want, we can trace it. Okay, so A goes with E. B goes with D. And then C goes with C. So these two guys go together. Which of the following must be true? Okay, we kind of talked about this, right? We kind of talked about this already. These two lines need to be parallel. So AB needs to be parallel to DE. Otherwise, those corresponding angles won't be equal. See how these guys are like alternate interior angles? They have to be parallel for them to be equal. So it's kind of like, it's true both ways. Anyway, we already talked about this. Pretty much anytime you see this kind of hourglass shape, you should kind of be thinking, oh, okay, if these guys are parallel, then they're similar, and vice versa. If they're similar, then those lines are parallel. Okay, so 9 is C. Good. Yep, we already talked about that. Arc FG, okay, so that's this one, is congruent to arc GH. Okay, that's that one. And the measure of angle G is 30. Okay, that's this one. Okay, so we kind of talked about this already, guys. The angles, see how they touch GH and then this touches FG? They are proportional to the arcs across from them. So if the arcs across from them are equal, then those two angles are equal. So this one is equal to this one. So now if you want, you could call each of these X, or just treat it like an isosceles triangle. So 2x plus 30 equals 180. And then we subtract 30. And we get 150. And then we divide by 2. And we get 75. So x is 75. So both of those angles, both of these angles are 75 degrees. So that is kind of the idea. I think it's C. Great, we're doing good. Okay, great. So we want to find the length of side BC. Let's label that with an X. Let's also circle the angle we care about, B. And sine of B is 5/13. So I'm actually going to be really particular to use the A here. So 5A. I'm going to use a different color too. Opposite. Hypotenuse. Okay, so do you see how the actual triangle, its A is 2. So the actual triangle is double. 13 times 2 is 26. And again, guys, opposite across from the angle, and then hypotenuse across from the right angle. So it's times 2. So A is 2. So the actual side of AC is 10. And if you want, you can now go do Pythagorean theorem on this like kind of original triangle. So that's what I'm going to do. A squared plus B squared equals C squared. The legs. Okay, 10 squared plus X squared equals 26 squared. We get 100 plus X squared equals, I don't even know what 26 squared is. Let's see. 676. Subtract 100, we get X squared equals 576. And now we are going to take the square root, and we get X is 24. And that is correct. So, again, guys, really important. I know we gloss over it because in most problems it doesn't matter, but sometimes it does matter. The trig ratio is simplified. It does not represent actual side lengths. So it just tells us it's in the ratio of 5/13. So if you put a 5 here and then use 26, that would be wrong, okay? So we had to see that the 13 is half of that 26. So we need to not use 5, we need to double it, 10. Great. Okay, so we're going to, first of all, you should recognize right away you have two angles equal, base angles. So these two guys are the same because it's an isosceles triangle. I don't even think that's helpful for the question, but that's just something you should notice. It's an isosceles triangle. Okay, now we're going to drop a perpendicular because we want to find cosine, so we need to draw a right triangle. And isosceles triangles, when they get cut in half, the base gets cut in half. So this is 16. And 32 divided by 2 is 16. And that's it. This is x. And this is 24. So we're going to do cosine of x opposite is across from the angle. Okay. Hypotenuse is across from the right angle. And adjacent is the last side. Okay, so we're going to do adjacent over hypotenuse. So adjacent over hypotenuse, cosine, so ca toa, C-A-H, 16 over 24. Put that in a calculator, simplify it, and we get 2/3. And that is our answer. So I guess it was kind of important. You did have to realize that it was isosceles. If it wasn't isosceles, I don't think you could say that this is 16. It doesn't cut it into 2 equal halves unless it's symmetrical. So anyway, when you see two angles or two sides equal in a triangle, your mind should be screaming isosceles. Okay, I have no idea what's going on with this one. Line L is parallel to line M. Okay. Points A and B lie on line L. Okay. Points P and Q lie on line M. ABP. ABP, so that's that one, has a measure of 21. And AQB, okay, AQB has a measure of 76. What is the measure of PAQ? Okay, so that would be this one, PAQ, and I'm going to label that with an X. Okay, interesting. We definitely got to do something with the parallel. I'm seeing some, if I extend this, I'm seeing some alternate interior angles. So I think this one's 21. And I think give me a second. Oh yeah, I missed something. ABP has 21. I should label what I'm coming up with in a different color. But QAB also has a measure of 21. That seems important. Okay, so this is an isosceles. That's a triangle. 180 minus 21 is 138. So vertical angles tells me this one is 138. And then you could do 180 minus because it forms a straight line with one of those other angles. So you could do 180 minus. And we get 42. And I want to say this one is also isosceles. I'm not sure what grounds I have to say that. Let me see. No, it's not. But this one, I definitely think this one goes over here. I'm trying to think what my reasoning is. Like how can we use parallel lines? I'm not sure. I'll have to come back to that. Okay, so we look at this triangle, and these have to add up to 180. So x is equal to 180 minus 42 minus 76. And 180 minus 42 minus 76 is 62 degrees. That is the correct answer. All right, let me see if I can come up with something for the angle at the end we did. All right, I see what's going on. So this one's 21 because of alternate interior angles. Now, these two top and bottom ones are isosceles triangles. So this one is equal to this one because they have base angles equal. Now this bottom one, we don't know that it's equal to that one, but we know that those two sides are equal to each other as well. So this one, I'll use 2 tick marks, is equal to this one. So now I have 2 triangles next to each other, the kind of more oblong ones, and their angles are equal. They're congruent by the SAS. rule, SAS postulate, side, angle, side. See, they both have side, angle, side. So the reason why we could pull this 76 over here was because the left triangle and the right triangle are congruent by side, angle, side. Great, very tricky. Okay, let's go on to the next one. Okay, the semicircle shown has a radius of r inches and chord CD is parallel to the diameter AB. If the length of CD is 2/3 the length of AB, what is the distance between the chord and the diameter in terms of r? Okay, give me 1 second. Alrighty. Okay, so we're going to call AB is a diameter, not a radius. So we're going to call him 2r. CD is 2/3 of AB, it says. So we're going to do 2/3 times 2r, which is 4/3 r. So we can put that over here. Now we're going to find the perpendicular distance by drawing a right triangle. You can go from either C to D. Why don't I go to D? Okay. So this distance between them is what we want to find. So we don't know that. Let's call that x. This distance, this distance here is a radius. So we can call that r. And this side over here is half of 4/3 r. Well, half of 4/3 is 2/3. So we're going to use the Pythagorean theorem, a squared plus b squared equals c squared. That's kind of a theorem they test you on once in a while, is that if you draw a perpendicular from a chord to the center, it cuts it in half. Okay, so we got x squared plus 2/3 r in parentheses squared equals hypotenuse squared, so r squared. We get x squared plus 4/9 r squared equals r squared. We're going to subtract 4/9 r squared from both sides, and we should get 5/9 r squared. Now we're going to take the square root of both sides, and we get x equals square root of r squared is r, and then we're going to do root 5/9. But a really nice thing you can do here is 9 is a perfect square. So the square root of 9 is 3. So we can write it as root 5/3. And I believe that is our answer. That should be D. Let's see if that's correct. It is. All right, very good. I think that was the last question. Let's go back to the title slide. Okay, that completes the lesson. Please like and subscribe for more digital SAT math content. If you're interested in my tutoring services, the link to my website will be in the description. I tutor SAT math on all math subjects from about 7th grade to AP/early college level. Thanks for stopping by, and good luck studying.